So this presentation is called Decentralization and Its Discontents. This slide normally has my headshot on it and the word hi, but it's not loading. So my name is Sarah. I am an artist and software engineer. I've been working in the blockchain space for 3-4 years now. And I'm currently working on a project called Circles UBI, which is a universal basic income experiment built on the Ethereum blockchain. But that's not what I'm going to talk to you about today. I'm also one of the co-organizers of a conference called R-Networks. R-Networks is a conference about all aspects of the distributed web, rather like this one. And it's taking place in Toronto in September of this year. And if this interests you, the CFP is currently open on our website. So I've given this presentation before, versions of it twice. Once is at a conference called Radical Networks here in Berlin in the fall, and the other is at Ethereum DevCon 4. So I'm sorry if you were in either of those presentations. There is some repeated content, but there's also some new material, so hopefully there's still something to entertain you. And finally, I work in the blockchain space, like I said, so a lot of my examples are from there, but it's my hope that they can be relevant to the broader peer-to-peer community in general. So this is a totally not comprehensive overview of the tools of the decentralized web. And I think what's interesting about it is that it's hitting really all layers of the network stack. So from the network layer, we see renewed interest in community mesh nets, decentralized name servers, the data protocol layer that many of you work on, IPFS, DAT, SSB, most blockchains, an application layer to interact with the data protocol layer. But also with these things, we see interest in the project of decentralizing governance, this sort of soft space of how we make decisions. And here we see things like Lumio and most DAOs. Our agenda for the talk and this presentation is framed as a bunch of questions. And it's pretty low on answers to them. I began this research to dig into some of the things that I felt were under-discussed in the decentralization movement, but I didn't necessarily come to any conclusions. I hope it can be interesting to you anyway. Sometimes I think just having a good question is all you need. So in order, we're going to talk about what is decentralization? Are we sure that we know? Do we want decentralization? Because let's not assume that we do. And finally, are there limits to decentralization? Because it may turn out that there are. So first off, this is more complicated than you might think. So conventional explanations of decentralization are often unsatisfying. Like I said, it's an antonymic definition. What does this mean? The problem with this is we have this thing, and maybe we can name it, and maybe we know what it is, and it's centralization. But what about all these other things that all aren't centralization? Are they all the same thing? What are the names for all the different things that all aren't centralization? The origin of the word decentralization is in the mid-1800s during the French Revolution. Alex de Tocqueville was writing about how it began as a push towards decentralization, but became, in the end, an extension of centralization. Which really reminded me of this Hannah Arendt quote, "The most radical revolutionary will become a conservative the day after the revolution." And indeed, decentralization is still more often used in a political or organizational context than a technical one. After I came up with the title for this talk, I found out it's also the title for a book. The subtitle is An Essay on Class, Political Agency, and National Perspective in Indonesian Politics. The top Google definitions are the transfer of authority from central to local government and the movement of departments of a large organization away from a single administrative center to other locations. So these are all political. And I think there's some irony, maybe, to being part of a supposedly decentralized system that denies having explicit governance. And I think it's worth noting also off the bat that even in this political or organizational context, the concept of decentralization has been a component of many political movements, some very at odds with one another. So for example, there's a strong free market rationale for decentralization. This is from a passage about information markets, and the sentence before it cites Adam Smith, and the sentence after it cites Friedrich von Hayek. And it describes, how a free market is decentralized because we have these rational actors moving independently, creating wealth in society without a central coordinating party. But there's also an entire movement called Decentralized Socialism. And this is a passage talking about how Mao Zedong's actions during the Cultural Revolution was a reaction to the centralization of Soviet Russia. So really a dizzying range of thinkers have called for some kind of decentralization, from Frantz Fanon to the International Monetary Fund, to the Kurdish Revolution, to the founding fathers of the United States. So does it turn out that this is the political compass of decentralization? And to be honest, this is a big part of why I started this research. For me, thinking about how to reconcile myself with this fact and trying to move towards a world I thought I believed in, I had arrived at the same forms, or at least the same marketing terms, as those I profoundly disagree with. And of course, that's also what's interesting about decentralization. Kind of like universal basic income, its cross-partisan support lends it this gravitational pull, but simultaneously a constant need to untangle. So sometimes people say it's more accurate to say what we're doing is re-decentralizing the web. The early internet was decentralized, but was it? And if so, which early internet was this touchstone of decentralization? Often people say Arpanet, the predecessor to the World Wide Web, which was a network funded by the Department of Defense. This is one way you might map Arpanet. This is a logical map of nodes in the network. This is another way you might map Arpanet. The first 4 nodes were at UCLA, Stanford, UC Santa Barbara, and the University of Utah. These were elite universities. This is hardly open access. And indeed, all the early Arpanet nodes were universities or big technology companies. So maybe this was decentralized geographically or architecturally, but hardly, for example, amongst social classes. To complicate things more, the development of Arpanet was to some extent motivated by the desire to have networks that could withstand catastrophic partitioning, something which we still often discuss as a goal of decentralized networks. But here it was with a Cold War military motivation, namely to have a network that could survive nuclear war. There are somewhat contradictory quotes from this time, some saying this was a motivation, some saying it was a motivation of earlier work, but not specifically Arpanet. Nonetheless, it was certainly a military-funded project. And these arguments about surviving massive segmentation are ones we hear even now in favor of decentralization, like in the case of a natural disaster. But do we feel the same way about them when it's to protect the military interests of a nation state? And indeed, this image, which to me has come to represent the meaninglessness of decentralization as a marker, in its ubiquity and semantic float, this says live, laugh, love, was created for the United States Air Force Project RAND in a paper called On Distributed Communication. But of course, Arpanet was not the only form of the early internet. For example, Usenet was its contemporary. And it offered a very different vision of decentralization. So Arpanet was active from 1969 to 1990, Usenet from 1979 to actually ongoing. And Usenet is similar to a bulletin board, but instead of a single server administrator, it features a constantly changing constellation of servers, structuring messages into news feeds and threads. The name Usenet comes from users network, and you could make a case that in terms of access, Usenet was much more open. I think it's very telling that at the time it was referred to as a poor man's Arpanet. There was a bridge built between the two networks in 1980, and communication on the Arpanet from Usenet users could be silenced by Arpanet at any time without their consent. And indeed, it was colloquially referred to as the Iron Curtain of Arpanet. Speaking of Iron Curtains, by the way, I found this in the course of my research. The first post to Usenet from Berlin after the wall came down, November 1989. So Usenet also has a precedent to BitTorrent. It was used for file sharing, and indeed it still is. This headline is from 2019. So I think it's worth noting that access to Usenet is neither completely free, nor completely open, nor really peer-to-peer the way we might think of it today. And I don't want to fall into the trap of idolizing any particular historical touchstone, because really when I hear re-decentralize without context, without feeling like there's any strong reference to which early internet is the decentralized vision we want to build, I kind of just hear make the internet decentralized again, which you can respond to the same way you might respond to make America great again, which is, yeah, when was it great? Which historical America, and great for whom? I don't always have to make the memes myself. So to return to Tocqueville and Arendt, and this idea of centralization growing out of decentralization, I want to consider that the fundamental character of decentralization might be cyclical. Arpanet becomes Usenet, becomes AOL, becomes BitTorrent, becomes YouTube, becomes DAT. And instead of imagining that our work could ever really be done, we might instead do better to find our sea legs and accept that the ground beneath us will shift again and again and again. And know that even if we accept that centralization grows out of decentralization and vice versa, it doesn't necessarily follow that the work we all do here is pointless. All right, so we may not necessarily know what decentralization is. Can we measure it? This is one way people like to try. The Lorenz curve or Gini coefficient is a measurement often used to assess the decentralization of wealth. And there's a few components in this graph. This diagonal line, straight line, is the curve that we would get if wealth distribution was totally uniform. So this is if 10% of the population had 10% of the wealth, 50% had 50%, et cetera, et cetera. The Lorenz curve is what we get when we plot the actuals, and the Gini coefficient is the difference between them. This is from an excellent article called Quantifying Decentralization by Balaji Srinivasan. And he plotted the top 100 cryptocurrencies according to wealth distribution, and we can see that we're very far away from this line of perfect equality. Also from this article, Srinivasan describes how a decentralized system like Bitcoin is composed of a set of decentralized subsystems like mining, exchanges, nodes, developers, clients, and so on. And I think maybe it's helpful here to borrow the term intersectional and to think about intersectional decentralization. And if we imagine decentralization as this shifting Cartesian plane of overlapping decentralizations, we find that none of them really make sense to discuss in the absence of another. We don't get the complete picture. Network analysis offers different paradigms for measuring centralization and correspondingly decentralization. So this is looking at algorithms for determining the centrality of any given node on a network. Here are 6 popular strategies done on the same graph. And you'll see that the red nodes are the more central ones. And these give us very different conclusions about the centrality of any given node, which I think really echoes the understanding that decentralizations are many and intersecting. So not only do we have different types of centrality, we also have different types of networks. Here are 2, exponential and scale-free. So what characterizes the exponential network is across the network, we have a meaningful number that is the average of nodes that any given node is connected to. In the scale-free network, this is not the case. Across the network, the number of nodes that any given node is connected to is governed by a power law, which you might also know as a fat tail graph. And what this means is that the average does not give meaningful insight into the data. And instead, we have this pattern of some highly connected nodes that sort of skew our understanding of average. If we removed several of the most highly connected nodes, we would get a very different picture of the network as a whole. And the properties that apply to these networks apply to networks of many different kinds. For example, communications networks, but also biological networks, social networks, how malware spreads through the internet, but also disease vectors through a population. And if this is a new or alienating way of discussing networks for you, let's ground it in something familiar and return to our popular decentralization infographic. So the exponential network probably maps best onto the third or fully decentralized version, where we have this evenly distributed nodes. And the scale-free network probably maps better onto the middle section of the infographic, where we have this pattern of some nodes being much more highly connected. Right now, the centralized internet as we know it, in terms of routing and infrastructure, most closely resembles a scale-free network. This is also the design that was advocated for by the original DARPA paper. It turns out these networks have very different properties under attack. In an outage, when nodes are going randomly offline, the connectedness of the exponential network, or the perfectly flat decentralized network, will degrade much faster than the scale-free one that shows these patterns of highly connected nodes. But in a targeted attack, where an attacker is choosing nodes based on their connectedness, the scale-free network will degrade much faster. So you can see what this looks like on a graph here. These blue squares are a scale-free network under random outages, and it can withstand significant outages before you see reduced performance. But under attack, things really fall apart much faster. And this graph here is looking at what we get when we have catastrophic failure, so failure states of the network. When the outage or attack becomes so specific that the network fragments. And again, we see similar behavior. So the scale-free network, like the centralized internet we know today, will keep bigger chunks for longer in the case of random outages. But under attack, it will fragment the same way as the exponential network and even faster. So the reason this is relevant to our work on mental models for decentralization is because the amount of times I've heard flat topography and equal peer distribution described as ideal, versus the ways that networks which feature apparently in some ways more centralization with more highly connected nodes can sometimes offer more resiliency and efficiency. It's almost a parable of the decentralization movement that networks centralize for efficiency and decentralize for resilience. But it turns out the words resiliency and efficiency aren't actually that helpful in the absence of a threat model. And when we start to quantify them, the picture gets both more clear but also more complicated. This is not a map of the internet. This is a map of flights in the USA, specifically Delta Airlines. So airline networks are another place we see this type of variance in network topology being studied. In airline networks, it's called the hub and spoke model versus point-to-point, with hub and spoke mapping onto the pattern of more highly connected nodes. And most airlines adopt a hub and spoke model because it allows them to capture economies of scale. They can, fly a bigger flight between the hub networks and smaller planes on the spoke routes. They pay less in airport fees. So economic trade-offs of these network topologies have been well studied in the case of airlines. And this can also work on informing our heuristics about these different network topologies and how they interact with decentralization. I think it can also speak to how centralization grows out of decentralization, because in the US, the adoption of the hub and spoke model is timed to the moment of airline deregulation. So we started to see this pattern form once market forces started to shape airline routes. All right, so part 2. Do we want decentralization? And I think this deserves to be an open question, or at least one we don't forget it's possible to ask. If we accept that there's no canonical decentralization and grant that there's maybe no way to have all possible decentralizations, then which decentralization do we want? Looking at whether we want decentralization, this is from a recent post by Tony Shang, where he analyzes the frequency of the word decentralization, which seems to indicate a surge of recent interest. We go from 0 mentions of the word in the Bitcoin white paper to something like 44 times in a paper last year from Vitalik Buterin. I did a bunch of Google Trends searching to see if this pattern from our communities was significant enough to be reflected in the macro internet. And I do think both of these graphs have a slight slope, more visible in the bottom one. This is for decentralization, this is for decentralized. So it looks like maybe the answer is yes. You all want decentralization enough to come to a conference about it. But let's consider a possible pitfall of decentralization. The NS, if you don't know, is the Ethereum name service. And this tweets when new names are bought on it. So this tweet is showing us that stormfront.eth was just purchased. This is in July 2017. The Daily Stormer was also registered just a couple weeks earlier in May 2017. And this is around the time that GoDaddy, Google, Cloudfront, and Network Solutions canceled the accounts of these sites. Cloudflare published a blog post explaining both their reasons for doing this and why they think it's dangerous, which frankly came back to decentralization, citing increasing dependence on a few network giants as one of those dangers. So the first sentence here illustrates the chief danger of centralization quite succinctly. Our terms of service reserve the right for us to terminate users of our network at our sole discretion. Which is exactly the same situation as a country, taking out access to a website, like we saw with Turkey and Wikipedia, or even the internet as a whole, which we saw in Cameroon a couple years ago. But this specific action on the part of Cloudflare was very popular, even amongst the decentralization community. So without making any arguments in favor of or against what these companies did, I would simply suggest that to be in favor of this action and simultaneously in favor of a perfectly censorship-resistant DNS is logically inconsistent. In a related example, this is a Twitter bot that tracks the trading activity of neo-Nazis or their suspected addresses. There's a lot of it. This is another example of a decentralized network being used to host content that might be repugnant to its users. So this poll is asking, would you stop running your full node if you found out there's child porn encoded in the blockchain? And the reason I bring this up is not really to ask about any of these specific examples, though certainly each deserves consideration, but instead to ask, is there anything that could be in the blockchain or in your IPFS node which would stop you from hosting that node? Is there X such that you would stop participating in the network? And I think it's worth asking. And it's worth asking with the understanding that the system we are already using contains implicit answers in its protocol design, in its governance, or in its lack thereof. And you could argue, if I don't like what's in the blockchain, I will fork it. I already have this freedom. And maybe you could even say we have this marketplace of altcoins. So if I don't like any one network, I could move to another. And I think this is a valid argument. But if we're going to posit this as a solution to lack of governance, then I think we need to get a lot more real about planning for contentious forks and getting ready to move our applications between chains or between different decentralization protocols. In an interesting counterexample, there's a far-right pub on Scuttlebutt. And I want to thank my fellow speaker, Andre Staltz, for pointing me to this thread about it. Because content syncs through the social graph, an island can form that is largely isolated from the main SSB continent. And this one is specifically isolationist, warning its users not to follow any mainstream pubs. And when an island does connect, you can trace the path of the connection. And that's what people in this thread were doing, seeing how this content had ended up in their view of the network. And in this thread, the SSB community is discussing features like subscribable block lists, sort of like crowdsourced curation. And the concern of some users was posted to scrub the local database. They did not want to host the content they did not like. And I think this is interesting because the SSB community's protocol, and therefore its model for governance, has different properties to a large degree, I think, because it lacks any concept of global consensus. So, we may not all want decentralization for the same reasons. And I'll let you interpret this phenomenon, being our competing motivations, which certainly exist, and decide how and if you want to reconcile which of them. This may be either a success or a weakness of the decentralization movement. You might say we've decentralized our motivations. And so finally, part 3. Are there limits to decentralization? In the blockchain world, we talk about the scalability trilemma, and this is from the Ethereum wiki. So when designing a blockchain, these are areas you have to make trade-offs within, kind of like a cap theorem for blockchains. So one of them is decentralization, and here it has its own definition, which is that any node on the network doesn't need to have a lot of compute resources. It can run on, maybe a normal laptop. And we have scalability, which under this definition means the network is able to process more transactions than any one node. And security, which is the amount of compute resources you need to attack the network. And of course, decentralization is on this list. It's a stat that we could lower in order to improve these other qualities. When we talk about scalability, it's like a blockchain catechism to compare it to the amount of transactions per second of something like Visa. Visa processes 24,000 transactions per second. Another way to understand this statement is that Visa has dropped its decentralization stat to 0 and maxed out its scalability. But of course, this is also fascinating because Visa thinks of itself as a decentralized organization. The founder, Dee Hock, has written extensively about attempts to decentralize power within Visa. He's written about what he calls chaotic organizations. And on the subject of scalability, this is Tim Berners-Lee describing the World Wide Web. It had to be completely decentralized, he wrote. That would be the only way the system could scale. Which is to say, apparently not everyone's decentralization character controller has the same trade-offs between decentralization and scalability as the blockchain world. But I think both looking at the story arc of Tim Berners-Lee and the World Wide Web and also Visa could call to mind this cyclical decentralization again, especially as we reflect on how Visa and MasterCard's blocking of donations to WikiLeaks in 2010 is still a pretty compelling use of cryptocurrencies. And what about manufacturing, to descend to a lower layer of the stack? Because right now, no matter how much we talk about decentralizing the network and application layer, how often do we consider the centralization of the manufacturing pipeline or the supply chain? There are many types of chain in this world. So for example, only 5 countries in the world really mine rare earth minerals. There are really only 3 major manufacturers of RAM chips. This is a graph of their market share. And so you can see that if manufacturing RAM were a proof of work game, Samsung would be 51% attacking it. And we've already seen cases where natural disasters have caused price surges. So we saw RAM prices spike 8% and NAND flash memory prices spike 20% in the wake of the 2011 earthquakes. And this is because Japan accounts for 35% of global flash memory production and 13% of RAM production. To descend to an even lower layer of the stack, possibly the lowest layer where computers are rocks, looking at rare earth mineral mining, we'll see a shocking 91% of the United States' rare earths comes from China. So if there ever were to be a serious natural disaster in that part of the world, the effects would certainly be felt. And the US knows this. This is a headline from just a couple days ago discussing how the reliance on Chinese rare earths constitutes a national security crisis. And you can also see effects of it in the US-China trade war. Rare earths were left off the tariff list because to tax them would have such significant effects. So of course, there is a movement called decentralized manufacturing, and this overlaps with the maker and open source hardware movements. So there are projects like the Libra router, which is a mesh-first open source hardware project. The Raspberry Pi, I think, falls in this category. 3D printers, the RepRap project. But having spent considerable time in manufacturing startup, and as the former maintainer of an open source laser cutter, I can tell you that the tools available to open source hardware enthusiasts are really nowhere near the precision or reliability needed to make something like a computer. There are centralizing factors to manufacturing in the form of factory startup costs. So it's an estimated $3 to $4 billion to build a new semiconductor plant. There are economies of scale in terms of manufacturing, just like we saw with the airline networks. And there's also expertise centralization. So a fun story from my time in manufacturing, I worked at a company that made glasses, and I don't know if any of you even know this, but there's a metal wire that runs through the temple piece of your glasses. And we had a machine that did nothing but inject that wire into the plastic. And so we ordered one from China, but there was no English manual. They had shipped so few of them to North America that they had never had any need to translate it. So expertise centralization. And also the simple fact that resources are not evenly distributed on this earth. So the technology that we have casual familiarity with is actually the pinnacle of an advanced and centralized manufacturing process that it's easy for us to take for granted. In the blockchain world, we have ASICs, which are application-specific integrated circuits. So this is hardware made specifically for calculating hashes, solving the proof-of-work puzzle. And it's for doing this one very specific type of computation as efficiently as possible. But again here, there are prohibitive costs. So building a new ASIC costs an estimated $5 million, but more realistically, $6 to $8 million to develop. So this is a powerful centralizing force. Again, there are economies of scale in terms of manufacturing. And I want to thank my friend Sam Hart for pointing me to a really fascinating article by Siacoin that gives you a lot more information about ASIC manufacture. One of the things I found is that with the exception of Bitcoin, all cryptocurrencies today have a single dominant mining hardware manufacturer. And this is complicated too, because with significant sunk costs in hardware, cryptocurrency miners have a significant incentive to maintain the value of the network, which is to say that even when the hash rate approaches or exceeds 51%, miners who have this specialized hardware tend not to engage in bad behavior, because to do so would be to trash their investment. This is a website called Are We Decentralized Yet?, which gives you breakdowns of the top cryptocurrencies and the amount of hash rate that is controlled by the few main miners. And so finally, the recursive question. Can we decentralize the building of decentralized networks? Like I talked about with the operation manual for the Glass's temple coring machine, specialization and centralization are tightly connected concepts. A technical expert is often or can become a central point of failure in a system. So let's look at some stats from GitHub. This is Geth, the main Ethereum Golang client, and 52% of the commits are from 1% of the contributors. This is then plotted on the Lorenz curve, and again, this is hardly an equal distribution. IPFS, we see the same story, 41% of the commits from 2% of contributors. And DAT is a similar picture, 82% of commits from 6% of contributors. And of course, I have not systemically analyzed this. I suspect it's fairly common, really the norm for open source projects and non-peer-to-peer projects too. I think it's probably inevitable, given the nature of skills like programming and maintaining network infrastructure. These skills are specialized, they require significant time commitment to develop, but it highlights that specialization is a form of knowledge centralization. A useful one that has allowed us to, for example, have the manufacturing pipeline we just talked about. For example, the scalability of everyone in the world, or even most people, becoming proficient enough in Golang to contribute to Geth is unlikely, and more so, possibly dangerous. Because really, to take this idea to its absurd conclusion of complete knowledge decentralization is to have a world where everyone would be knowledgeable enough in everything to contribute to it all once, which is ridiculous. So of course there are things we can do to improve the new developer experience and the onboarding ramp of new contributors. Certainly we should do these things and take them very seriously. But there's probably a limit to how much we can ever assume something like this to become distributed. So in conclusion, the main questions we've covered. Are there limits to decentralization? Do we hit them in the terrain of manufacturing, in the limits of human brains to hold specialized information, in the distribution of matter on the surface of the earth? What is enough decentralization? Do we want decentralization? And if so, which decentralization do we want? Who and what is the decentralization we're building enabling? And what underlines all of this? That there are many decentralizations, that they are probably cyclical, and all of them may prove meaningless or risk becoming just ideological background noise unless continually, carefully, and thoughtfully examined. Thank you.